Good morning. In today's session, I would like to discuss about the thermodynamic properties of the system. Now, normally the thermodynamics is a science which is applied to three states of any matter. One is solid, liquid, and gas. Now, the state of any of these three matters can be explained by the properties of the substance. The various properties which define these three are mass, volume, temperature, density, pressure, etc. Now, these properties can be classified into two types. One is intensive property, other one is extensive property. The intensive properties are independent of mass. That means they are not depending upon the mass of the substance. The example of intensive properties are temperature and pressure. So whatever the mass may be, they will be having a uniform temperature and a uniform pressure at any point of the substance. The extensive properties are depending upon the mass. So the examples are volume, if the volume increases, the mass will increase. If the mass increases, the volume will increase. So the volume is an example of extensive property, and specific weight. Again, volume specific weight is something which is intensive property because the specific weight W is given as weight of the weight divided by volume, Newton per meter cube. That means if the weight increases, the volume increases, the value will be same. W by will be the same. If you increase the W, the volume increases. If you decrease the volume, the weight will decrease. So the specific weight, density, they are all intensive properties. And the volume, weight, mass are extensive properties. So this is all about the thermodynamic properties of system. Now I'll clearly explain about what is pressure. If you consider a system at some particular consider small elemental area delta E, and here small delta Fn is the force that is acting on this area. Now the pressure is defined as limit delta A tends to 0, delta Fn by delta E. So this is the pressure or instantaneous force acting at a small area, that's pressure. Now, the units of pressure are pascals. That is 1 Newton per meter square. Now, in thermodynamic systems, 1 Newton per meter square is very small. So here we consider kilopascals or megapascals. Kilopascals is 1000 Newton per meter square, megapascals is 10 to the power of 6 Newton per meter square. We can measure pressure by a Bourdon tube and a manometer. This is a Bourdon tube, and some liquid is flowing. So the Bourdon tube takes small inlet, and the liquid will be inside. And because of this, there is a linkage and there is a gear system, and whenever there is a pressure, this button will be moving, and because of the linkage will move, and if you calculate properly, you can get the gauge pressure of the water fluid. Now the absolute pressure PA is equal to gauge pressure plus P atmospheric pressure. The other method of measuring pressure is manometer. So consider a pipe where there is a flow is there, and connect this to a manometer. Now this manometer is consisting of some mercury. Now because of this pressure, there is the right hand side mercury will be raised and the left hand will be lowered. So here gauge pressure is greater than atmospheric pressure, so we are adding both of these. In some cases where the pressure in the pipe is lower than atmospheric pressure, the manometer will be showing the left hand limb will be higher and right hand limb will be lower. This distance is Z. So here vacuum pressure is equal to minus of PV, absolute pressure is equal to minus of PV plus P atmospheric. Now this pressure, gauge pressure, is given as rho G into Z. Z is the height of the column of the liquid. This is how we measure the pressure. And the temperature can be measured with the help of thermometer. The mass can be measured with the help of a spring balance. The volume can be measured meteorologically. So this is about the properties of thermodynamic systems, classification, and various methods of finding out the values by using various apparatus like Bourdon tube or manometer, etc. Thank you for watching the video.